Welcome to the Trend Micro Deep Security 10 for Administrators video series. This collection of videos provides an overview of tasks that may be required as part of your work as an administrator in Deep Security Manager. While the Deep Security Firewall Protection module examines the control information in a data packet, the Intrusion Prevention Protection module examines the actual content and sequence of the packets. If the deep security agent is able to determine that the content in the packet is malicious, the packet can be dropped or the connection reset. In this video lesson, we will enable and configure the Intrusion Prevention Protection module to protect servers from known vulnerabilities. The Intrusion Prevention module protects computers from being exploited against known and zero-day vulnerabilities, as well as SQL injection attacks, cross-site scripting attacks, and other web application vulnerabilities. Intrusion prevention shields vulnerabilities until code fixes can be completed through a concept called virtual patching. It also identifies malicious software accessing the network and increases visibility into or control over applications accessing the network. Deep security agents look at the content of a packet to determine if it contains malicious content. It is able to determine if the content is malicious by referencing instructions within the intrusion prevention rules. If the content matches what the rule looks for, the packet is dropped and the event is locked. The Intrusion Prevention Protection module uses rules to shield computers from known vulnerabilities. These rules are created by Trend Micro engineers in response to discovered exploits and vulnerabilities. I've logged into the Deep Security Manager web console. Under the Policies menu, expand Common Objects, and under Rules, you'll see the different rules that are available for the protection modules. Click on the Intrusion Prevention rules, and in the right-hand pane, you'll see a list of all of the intrusion prevention rules that have been developed by Trend Micro. You'll notice that there's quite an extensive collection of rules. In this case, there's 60 pages of rules. One of the responsibilities of the administrator is to make sure that the appropriate rules are applied to ensure that any vulnerabilities in the operating system and applications that are running on the protected computer are going to be covered by the different rules. One handy mechanism that's available for doing this is to run a recommendation scan. Recommendation scans can be initiated manually, or you can create a scheduled task to periodically run scans on specified computers. A recommendation scan follows these steps. In the first step, the Deep Security Manager sends a query to Deep Security agents to initiate the scan. The query includes instructions as to where on the host computer the agent needs to collect information. These instructions are based on the detection rules and expressions that are included in every security update. Upon receipt of the query request, the Deep Security agent collects information about the host computer for return to Deep Security Manager. Features within the Deep Security agent obtain information for resources including registry entries, running processes, open ports, file system attributes, services, and more. This information includes not only information about the host operating system, but also the applications that are installed on the operating system. This information is used to determine the vulnerabilities that may exist on the host. Once the host metadata is compiled, it is sent to Deep Security Manager as an XML-based message. If the recommendation scan was initiated from Deep Security Manager, the information is returned synchronously with the query. Otherwise, it is sent as part of the regular Deep Security Agent heartbeat cycle. Once the Deep Security Manager receives the host metadata from the Deep Security Agent, it compares this information with the security information in its database to identify which rules need to be applied to the host. For example, if the service information collected from the Windows Service Control module indicates that Microsoft IIS is present on the host, then the rules related to this particular web server need to be applied. A list of recommended rules is displayed in the Deep Security Manager web console. The administrator at this point can then review the list and apply the suggested rules. Alternately, the rules can be applied automatically. Let's return to the Deep Security Manager web console and run a recommendation scan on one of the computers in the computer list. I'm back in the Deep Security Manager web console. Click the Computers menu and double-click to view the details for one of your installed computers. Select the Intrusion Prevention Protection module in the left-hand frame and notice in the Assigned Intrusion Prevention Rules section that no rules are listed. In the lower section of the display, you'll notice that no recommendation scans have been run, so we can click on the option to scan for recommendations. But in this case, you'll notice that you also have an option to automatically implement the intrusion prevention recommendations. I'm going to select yes, click Scan for Recommendations. I'm going to close the details window and notice that on the Client 1 machine, it's currently scanning for recommendations. It's going to take a few minutes for the recommendation scan to complete. The scan is now complete. Let's return to the details and take a look at the rules that have been applied. Click the Intrusion Prevention Protection module once again, and under Assigned Intrusion Prevention Rules, you'll note that there are 700 rules that have been applied. In this case, this is a Windows 7 operating system. It's an older operating system, so a lot of vulnerabilities have been discovered in this operating system, and our engineers have created the necessary rules to help protect against each of these. And you'll notice currently there are no unresolved recommendations because they've all been applied. New rules are going to be released on a regular basis as the engineering team uncovers new vulnerabilities. If you click Settings within the Computer Details window, under Recommendations, there is an option to perform ongoing recommendation scans. If you set this to yes, and then select an interval, for example, in this case, every 2 days, an automatic recommendation scan is going to be triggered, and any new recommendation scans that are suggested will be automatically applied. This also works in the other direction. For example, if the operating system has been patched by the manufacturer and there's a rule that's in place that was necessary to protect against a particular vulnerability, the rule will be removed because it's no longer needed. Let's take a look at another machine. On the Client 2 machine, double-click to bring up the details. Select the Intrusion Prevention Protection module in the left-hand frame. Notice that there are no rules that are currently assigned. In this case, let's apply the rules manually. So set the Automatically Implement Intrusion Prevention Recommendations to the default of No and scan for recommendations. Here again, it's just going to take a couple moments for the scan to complete. The recommendation scan has been completed. Double-click on the computer to bring up the details. Select the Intrusion Prevention Protection module. Notice that the Assigned Intrusion Prevention Rules list is empty. That's because we've chosen the option to assign them manually. Click Assign Unassign. And from the filter list, select the option Recommended for Assignment. In this case, we're only going to show you the rules that have been suggested through the use of the recommendation scan. As an administrator, you can now go through the list and select which ones you would like to apply to this system. Click to enable the different categories, and the rules within those categories will be enabled. Now notice in the rule list there is a column called type. There are a few different types of rules that are going to be assigned. Let's take a look at those different types. An exploit rule protects against a specific exploit. There could be as many rules as there are methods for using the vulnerability. A vulnerability rule, on the other hand, applies a virtual patch on the vulnerability, thereby rendering all exploits that use that vulnerability harmless. Vulnerability rules, therefore, can theoretically take the place of several exploit rules. A smart rule is a generic rule that provides virtual patching for multiple vulnerabilities. So let's take a look at how this all works together. So let's say on your operating system, a vulnerability is discovered. A hacker will create an exploit to take advantage of that vulnerability, and Trend Micro engineers will create a rule to prevent use of that vulnerability. Another hacker may create a second exploit. Trend Micro will create another exploit rule to protect, and let's say a third hacker figures out a different way of attacking that vulnerability. So in this case, we have 3 different exploits, and we have 3 different exploit rules to protect. Eventually, what we can do is take a look at the commonality within those exploit rules and develop a vulnerability rule. And this vulnerability rule will protect against all of the different exploits. So whereas before we had 3 separate exploit rules, now we have 1 vulnerability rule. Let's say a second vulnerability is discovered. So same type of situation, you have multiple exploit rules that are created for protecting against those exploits, and then those exploit rules are distilled down to a vulnerability rule. Eventually, we're going to take a look at the commonality in the vulnerability rules, and we'll generate a smart rule, and the smart rule will protect against both of these vulnerabilities. The creation of vulnerability rules and smart rules helps reduce the number of rules that need to be processed by looking for commonality within these rules. When all 3 rules are available for a particular vulnerability, they form a layered defense mechanism around the vulnerability. Let's show an example of how the intrusion prevention rules can be used to protect the system against a known vulnerability. I've logged into the Metasploit framework, which we'll use to launch an attack against one of our protected computers. On the computer, there is a known vulnerability that we can take advantage of. So under Exploits, let's select Windows and SMB. And double-click the known vulnerability. And what we're going to do is we're going to launch an attack against this particular system. So I'll type in the IP address of that computer. Click Launch. Note that I now have control over this computer from the Metasploit framework. If I right mouse click on the computer and select Interact, I can bring up the command shell for that computer and type commands which are executed on that machine. I'm back in the Deep Security Manager web console. So what we'll do, we'll apply the necessary rule to protect that system. And we'll do this through the use of a policy. Double-click on the classroom policy to bring up its details. Select the Intrusion Prevention Protection module from the left-hand frame, and under the Intrusion Prevention state, let's enable the Intrusion Prevention Protection module by setting it to on, and let's set the behavior state to prevent. This setting specifies the behavior of the intrusion prevention rules and can be set in a policy or on a computer. Detect behavior is useful for testing when you first apply a new set of intrusion prevention rules to make sure that they don't interfere with legitimate traffic. When set to detect, all of the intrusion prevention rules should be triggered and events are generated, but traffic is not affected. You should test new intrusion prevention settings in detect mode to ensure that service on your computers will not be interrupted by false positives. If, after monitoring the intrusion prevention events for a certain period of time, you are certain that no false positives are being generated, you can switch to Prevent, which will prevent rule triggering traffic from continuing. This setting only applies when the network engine is operating inline. That is, live traffic is being streamed through deep security. The rules will be applied to traffic and the related log events are generated. So let's save. And what we're going to do now is assign an appropriate rule to protect our system from that vulnerability. Click Assign Unassign. And from the filtering list, we're going to select it to display all of the necessary rules. So in this case, all of the intrusion prevention rules are displayed, and let's do a search to limit the display and only show the rules related to our vulnerability. In this case, there are 4 rules, so I'm going to click to enable these rules, click OK, and the policy is going to be updated to include these 4 rules. So you'll notice at the bottom here, there are 4 intrusion prevention rules that are assigned. So our policy has been updated. Let's go to the computers list and assign that policy to one of our computers. So in this case, the client 2 computer is the one that we're going to be attacking. So let's change the policy to use our classroom policy. Click Save. You'll notice that the intrusion prevention module is set to installation pending. So the intrusion prevention protection module is being installed on the client 2 computer. 4 rules are going to be applied. And you'll notice the task column is listed as sending policy. The policy has now been sent, and we can go test our connection to the computer again. Back in the Metasploit framework, I'm going to launch the attack again. The IP address of the client 2 computer is still displayed. Click Launch. And you'll notice in this case, the computer does not turn red, and you'll notice the connection has timed out. So in this case, the computer is protected and the Metasploit framework is no longer able to take advantage of that vulnerability. The Intrusion Prevention Protection module supports filtering of encrypted SSL traffic. In this case, the credentials that are required to decrypt the SSL traffic must be imported into the deep security agent in either PKCS number 12 or PEM format. Windows computers have the option of using the Crypto API directly. The credentials are required to give the deep security agent access to the private decryption key that it will need to decrypt the necessary traffic. The deep security agent does not support filtering SSL connections on which SSL compression is implemented. If the packet is part of an SSL connection, the deep security agent and the network driver need to decrypt the traffic to perform intrusion prevention filtering. If you're using PEM or PKCS12 credentials, the administrator must identify the location of the credential file and the passphrase to permit decryption. Each time an SSL packet passes through the deep security agent, the traffic is decrypted and analyzed. This decryption is applied to both incoming traffic and its corresponding response. When deep security agents receive a packet from the network, the packet is deferred while its content is analyzed. After the firewall protection module completes its analysis of the packet, it is handed off to the intrusion prevention module and the HTTPS payload inspection for analysis. The decryption engine is not able to re-encrypt the traffic that it decrypts. To preserve the original encrypted packet, a copy of the packet is created, the copy is decrypted, and then inspected. If the packet contains malicious content, then the packet is dropped. If the packet cannot be decrypted, then it is also dropped. If the packet does not trigger any intrusion prevention rules, the deferred encrypted packet is allowed to proceed to its destination. Two of the most common application layer attacks are SQL injection and cross-site scripting. Cross-site scripting and SQL injection rules intercept the majority of attacks by default, but you may need to adjust the drop score for specific resources if they are causing false positives. Cross-site scripting is a code injection attack that allows an attacker to execute malicious scripts in another user's browser. Rather than directly targeting a user, the attacker makes use of vulnerabilities in websites that the victim visits in order to get the website to deliver the malicious scripts. To the browser, the malicious JavaScript appears to be a legitimate part of the website, and the website acts as an unintentional accomplice to the attacker. The attack may occur when a web application does not properly validate or escape user input. If the user input is echoed back to the browser without escaping it properly or using proper validation, malicious HTML or script code may be executed by crafting malicious input. SQL injection is an attack in which SQL code is inserted or appended into an application or user input parameter. These are later passed to a back-end SQL server for parsing and execution. Any procedure that constructs SQL statements could potentially be vulnerable, as the diverse nature of SQL and the methods available for constructing it provides a wealth of coding options. The primary form of SQL injection consists of direct insertion of code into parameters that are concatenated with SQL commands and executed. SQL injection may occur when a web application does not properly escape user input that is used in SQL statements. Malicious input may result in executing arbitrary SQL statements. The intrusion prevention module is able to defend against cross-site scripting and SQL injection attacks through the use of the following out-of-the-box rules available in deep security. Both rules may require custom configuration for web servers. If you have output from a web application vulnerability scanner, you should leverage that information when applying protection. For example, if the username field on a login.asp page is vulnerable to SQL injection, ensure that the SQL injection rule is configured to monitor that parameter with a low drop threshold. This completes the Protecting Servers from Vulnerabilities lesson as part of the Trend Micro Deep Security 10 video series for administrators.